Hello viewers, how are you? Welcome to our channel Electrical Design Lab. Here I am Engineer Manoj Kumar Haldar, a power or distribution transformer specialist going to describe about the different losses of a transformer. So, dear viewers, how are you? Of course you are fine. So let's go with me. So in this lecture, how we will going to complete or going to learn about the knowledge. Let's see it first. Lecture sequences are: firstly we will understanding what is loss of an electrical machine. Then we will focus our attention on transformer. Are you ready? Next we will learn about the power loss in a transformer, and you should know why the losses happen in this transformer. We will discuss it more and more clearly, okay? Then we will learn about the conventional description about the losses that are described in your textbook. But in this lecture you will learn something very different from my point of views, more deeper into the losses. Are you interested? Sure, you are interested. Then we will know about no load losses and its subcategories with elaborate description. You will learn very much. Then our final topic will be on no load losses and its subcategories, also with elaborate description. So in this our lecture sequence, our first topic on loss. What is loss? What is loss? Very interesting topic. For electrical machine, what we are give to its input, we are not getting the whole power after processing. That's mean input power is not equal to the output power. So from your academic book, here is a definition for you. In this definition, the losses of any machine in a simple scientific way are the amount of difference between the input power to the machine and the output power coming out of it. So what is that? That is input power minus output power. What is remains? That is losses. Understanding? Losses equal to the input power minus the output power. Why losses happens? Because electrical machine process, okay, losses happen inside the machine while passing through it. While the power pass through the machine, that time the losses happens because of its processing. Okay, now you are clear what is losses. So now we will learn what is transformer. Transformer, it's a key equipment, very important equipment for power system, electrical power system. Without it we can't transfer or generate huge amount of power from one part to the other part of the world. This is only possible because of transformer. Do you understand? Of course you understand. So what is transformer? It's a apparatus, only a apparatus for reducing or increasing the voltage of an alternating current. Why we use this apparatus? to change the value of voltage or the value of current according to our desire. Understand? So transformer is what? Transformer is an apparatus which can transfer power from input circuit to the output circuit. Any physical contact, you look here, there is no physical contact, there is no wire contact. This circuit is separated fully from this circuit. Okay, so this is the primary part of this transformer and this is the secondary part of the transformer. And here what is that? It is the important part of the transformer by which we transfer the energy or power from primary coil to the secondary coil, that is called core. Okay, understand? So what is transformer? Transformer is a apparatus that is used in electrical system for changing the voltage or current according to the desire. So in this lecture, previous slide we already understand what is transformer. Now we will know why the losses happen in transformer. Okay, so look at the figure. Here source is connected to this coil, that is primary coil, and as it is connected, so current I1 is flowing through it. So what will happen? Flux will produce, and this flux will travel and come to the secondary part of this transformer. Okay, that means this flux will link with the secondary coil, and for that reason here voltage will be induced according to laws of Faraday's law of electromagnetic induction. By induction process, here we will get some voltage. If the secondary part, that means load, is connected with the secondary part, then current will flow through this circuit, and here this current is denoted by I2. So our concentration is here why the losses happen in transformer. So when this current flow the primary coil, then flux will produce, and every copper conductor, there is some internal resistance. What? Internal resistance. And for that reason power continuously losing, and inside the core, you look here, the flux passes through it, and this magnetic material has also an obstacle, that is called reluctance. After overcoming this reluctance, this flux has to come to this secondary coil. So for overcoming this reluctance, there is some power is used, and third one is eddy current because of magnetic flux with lamination steel silicon sheet. When flux passes through this core, this flux not only cut by the conductor but also cut by the core. What? Cut by the core, and for that reason the core induces some voltage, and circulating current around the core leg try to follow. And because the core material also have resistance, for that reason inside the core there is a loss, what is I square R. This is because of eddy current. We understand? Now transformer body eddy current, because leakage flux linkage with the transformer body. Let's assume what happens when primary source is connected to the primary coil. The flux produces. Do you think all the fluxes produces here link with the secondary coil? Not sure. Some flux will come out from this core and they are in air. Okay, these fluxes will link the transformer body. Why? Because this part we keep into a body, metal body, and the leakage fluxes are linked with the body, and for that reason the body, because of cutting flux, it induces some voltages, and in the body there will flow a circulating current, that is eddy current. So these are the reasons why losses happens in the transformer. I think you are not so clear. Don't worry, I am going to more detail about the losses. So in our next slide we will see here conventional description about the losses that we will read when you are reading in your prescribed book. So in your book there are written two losses. One is iron losses or core losses or no load losses, and another one is on load losses. That means resistance losses, that means copper losses. Okay, copper loss is what? It is because of resistance of winding. Resistance is R, copper resistance is R, and power will be I square R. These are the conventional method or conventional description about the losses. This is not interesting. Okay, next you will learn more about it. From my point of views, more deeper into the losses if I go, then I will categorize the whole losses into two categories. Why? Because our transformer may have two states when we connected it to the power. Okay, what are this? It may stay in no load, that means secondary load is not connected with the transformer, and on load, that means secondary load may be connected with the transformer. When transformer is not connected with the load, that means no load condition, the losses are hysteresis losses, eddy current losses, and dielectric losses. There are three subcategories of no load losses, and when the transformer is connected with the load, that time we call it on load, and the losses when the transformer is on load are copper losses, stray losses, conductor, eddy current losses. Understand? What are the losses? Copper losses, stray losses, conductor, eddy current losses. Okay, so little confusing. Don't worry, I will describe every losses. Here we will see 6 categories of a losses for a transformer. Inside the transformer this losses happens. I will describe every losses very clearly in details. Okay, so let's concentrate here. First of all, I will describe about the eddy current losses. Eddy current losses. What losses? Eddy current losses. Okay. Eddy current losses. What is eddy current? Before eddy current losses, you need to understand the hysteresis losses. Hysteresis losses. What is hysteresis losses and why this loss called hysteresis loss? We will understand from here. Hysteresis losses. So first of all, we need to know what is hysteresis. What the meaning of hysteresis? This word means the tendency of magnetism to stay in its old states. In its old states. In its old states. That means according to the Newton's three laws, the first law states that every thing states its own state. Okay, that means if we not apply any force on it, it will state as same as the present state. Okay, so hysteresis, when we know that transformer takes the alternating current, okay, alternating current. That means in complete one cycle, it flowing in two direction. For first half cycle, it flowing one direction, and for second half cycle, it flowing another direction. So what will happen when current flowing this direction? You look this direction, magnetic flux direction. This is the magnetic flux direction, because current is flowing the coil, and for that reason the flux direction will be this direction. This is the flux direction, and this flux is cut by the core. These are the core. This is the magnetic circuit, and for that reason the core, it you can imagine a very small particle, by consist of very small particle, and by this particle this flux will be cut, and because of that it induces some voltage, and because of voltage this is a material, and for that reason current will try to conduct in this direction according to the right hand rule. You see here, this thumb indicates the flux direction. What direction? The flux direction. And this the curl finger, is the direction of the magnetic flux, okay, is the eddy current, and this is the direction of this thumb. This thumb is the direction of the magnetic flux, and this curl finger is the directing the eddy current or circulating current path. Okay, this is okay. So this is a core. Of a three-phase transformer. Here these are the three legs. Here I am showing you the three legs of a transformer. Here this is a real picture. You look here, this is a real picture. Assembling core, stepping. These are the few steps of the core. I will tell it about the more details next. Don't worry. So magnetic flux will, while flowing through the core, then a circulating current produced on the core, and because of the I square R power losses happen inside the core, and this eddy current is not only occur in the core, it also occurs in the conductor, in the conductor, in the conductor. This is the circulating current direction. This is the circulating current direction. So what is the? It is a LT, low tension, or LV, low voltage coil strip conductor for the electric circuit. That means this is the low voltage side. This is the low voltage side. Here current, as the current is more and more than the secondary part, that's why we have to use the strip instead of the round conductor. When current is flowing through it, let's assume in this direction down to upper, then flux will produce, and the flux direction, let assume in this direction, and according to the thumb rule, the current, eddy current, the produced eddy current will flow this direction, and to reduce this eddy current losses, here is a technique. You look here, this is the copper strip, the copper strip, and each strip are very laminated, and all keeping together, there is another insulation on over it to bond it properly, otherwise it may detach from each other. So why this insulation, inner insulation? This insulation to provide an obstacle and provide an resistance for this eddy current, Now you understanding what is eddy current, or what is eddy current, why this is producing. I slightly deviate over the hysteresis losses. So hysteresis losses, what? So hysteresis losses, we know our alternating current is like that. This is one direction and this is for another direction. So we know when current flowing through this or this, then a magnetic field is produced. And every magnetic field has two poles. That means one pole is north and another pole is south. So one pole is north and another pole is south. This north and south pole will get reversed when this cycle comes. So from this one complete cycle, the polarity will change two times. But just few minutes back, we learned that the magnetism, the tendency of magnetism to its old states means the polarity north and south pole will stay as long as this positive cycle stays. When this is complete, that means this point, and the current is coming here, that time also the effect of this point north and south will stay the fixed position. So for that reason, we will clear it more clearly here. When we increasing the H is what? It is the intensity. Intensity is equal to the magnetomotive force divided by the length. Magnetomotive force is what? It's the N into current flowing this N number of turns coil. Okay. So here I is the variable, N is the fixed. So if we keep increasing the I, then flux will increasing. At a time that flux, if the increasing the current, then flux will not increasing. and that time if we again reduce the current, that means intensity, then within it the flux density will slightly reduce. But when the current is 0, there is a some magnetism inside the material. That means I previously told you north and south pole in a arrangement, this arrangement. When the current is flowing another direction, means this direction, this is the point, 0 point, where? Here 0 point. From this point the current in the negative path, so there is a some amount of current, this amount of current to need for making the zero of the magnetism, if we further increase the current, with the current the flux intensity also increase, and after some time that gets saturated, and after that if we increase the current, then the flux density will not increase. So from here the point of saturation, then we reduce the current or changing the reduce the current, and what will happen? Reduce the current, and what will happen here? With the decreasing of current, their flux density will also decrease, but it will slightly decrease. So when the current is 0, there is some value of flux, this amount of value, it is not being 0 with the current 0. So to make the flux density 0, this point we have to again apply this amount of current, but this is again the another direction, this is again the from here another direction of current, so after this amount of current, this cycle again is repeat, this cycle again and repeat. This is the intermediate position, while the pole, while this dipole are gets reverse, you look here, north is upper side and south is downside, and while they are getting reverse, then south is upper side and north is down side. So make this polarity change, there are some energy necessary. This is the loss amount of power, and it is the equal amount of the area under this or inside this curve. This loss amount of power is equal to the area inside this curve, so you understand, I hope, what is hysteresis loss. Eddy current loss you understand, hysteresis loss you understand. Another loss, that is dielectric loss. The dielectric loss is what? Dielectric loss means while you are given supply to it, these coils are insulated, this is a turn, this is a turn, every turns are insulated from other. So you look here, this is wrapped by insulation and this is also wrapped by insulation, but both of these turn carrying current, but between them there is a insulation present. So this is the property equal to a capacitor. According to the capacitor, what is capacitor? Capacitor is that when two metals are separated by a dielectric, then it will form a capacitor. So same capacitor will produce here, as the our current continuously changing. First half cycle this is flowing one direction, and for second half cycle this is flowing another one direction. For that reason the capacitance will also change. First time this may be positive and this may be negative, and second time this may be or could be negative, this could be positive. Okay, and this is not also the fact, the core also laminated, this is the core, you look here, this is the core, and this core will wrapped with the insulating cloth. So this will also form a dielectric. So capacitance may occur between the coil, and not only the coil, between the coil and also other metal part. And as the every time the alternating current change its direction, the capacitance will also change its polarity, and for this changing polarity there will some energy need, and this energy is being used to make the polarity reverse. The dielectric polarity is reverse, positive negative and negative positive, positive negative to negative positive. So this power is not used, this power we are not get in the output, this is fully lost. So this is called the dielectric losses. So you understanding about the no load losses. Now you will learn about on load losses. That means when the transformer is connected with the load, that time current will flow through the secondary circuit. As the current is flowing through the secondary circuit, so more current will be drawn in the primary current. So primary current, here all the current is flowing through the coil, and this coil are made of from copper. These are coil made of from copper conductor. That's why conductor has the resistance, and for its resistance here some losses, that means power losses, that means equal to I square R amount of power losses in the conductor while flowing the current through the secondary when load is connected. So you understand what is the no load on load losses, about the copper losses. Now you come on the stray losses. So what is stray losses? Okay, you see here, this is the core, and on it we first put the primary coil. That means we put the coil, LT coil, which is made of the strip, which is the made of the coil are winding from this strip, and this is put on the core. And after that this coil, this are the round conductor coil, this on the put onto this. Then this whole assembly are putting on this tank. On what? Putting on this tank. So just few minutes back we learned that all fluxes are not flowing this path. Some fluxes will deviate, that means are not linked with the secondary, so they are stay in the air, so when they are staying in the air, this flux, these are called leakage flux. This leakage flux will link with the body, not only the body, also the metal part, other metal part. This is the angle supporting for the core to tie them. Okay, so this angle, metal angle, and this body links with the leakage fluxes. Then some losses will occur in this body, or metal bar, because of eddy current, because flux is cutting by this, and these losses are called stray losses. And conductor eddy current losses, what is conductor eddy current losses? You look here, conductor eddy current losses, I already discussed about it. Conductor, here what are the number of conductor, or what are the number of strips? 1 2 3 4 5 6 7 8. 8 number of conductors, a group of conductors, inside them 8 number of conductors are present. Okay, and when flux is flowing, or flux is linking the conductor, then eddy current is produced inside the conductor. That's why these losses is again equal to I square R. Here I is the amount of eddy current and R is the resistance of the conductor. So we understanding what is conductor or eddy current losses. Do you understand? Of course you understand. I hope now you are clear all about the losses. There are 6 categories of losses in the transformer: hysteresis losses, eddy current losses, dielectric losses. When transformer is on load, that means load is connected, then more current is drawn from the sources, and these currents are the reason for the copper losses, stray losses, and conductor eddy current losses. Thank you very much for your kind passion and for your interest to learn more and more about the transformer losses. Hope to see you again with the another lecture. Be happy, stay well, take care, God bless you.